These are the solutions to question number 6 from the 2015 CHAOS examination paper. 6 part A, we want to show that the origin is asymptotically stable for this system using this Lyapunov function. And for part B, we want to consider this tent map and we want to list the S1 and S2, which are the set of points that never escape from the interval 0, 1, and show that they form a Cantor set, and then we want to find the fractal dimension of that Cantor set. So for 6 part A, here is our 3-dimensional system. Here is the Lyapunov function. So we find dv by dt. So dv by dt is partial dv dx dx dt plus partial dv dy dy dt plus partial dv dz dz dt. So you obtain this formula in the 2nd year. So this is the chain rule. If we substitute for x dot and dv dx dv dy and partial dv dz, we get this expression, which simplifies to dv by dt is minus 4y to the 4 minus 2z to the 4, which is less than or equal to 0. Remember, this expression can be equal to 0. So dv by dt can be equal to 0 only when y and z are both 0. But y and z are both 0 is the x-axis. But from y dot, if you look at y dot here, y dot is always minus y cubed. So away from the origin, the flow is always off the x-axis. So if a trajectory starts on the x-axis, it moves off. And as soon as it moves off, then you're entering this region. So you have these ellipsoids for the Lyapunov function, and your trajectories go towards the origin. So therefore, the origin is asymptotically stable. For part B, I've done rough sketch here of your f of x, and here is the line y equals x. Remember, when you iterate, you go up to the curve, across the diagonal, etc. So you can see that points remain in 0, 1 after the first iteration. So in here, if you draw this on graph paper, if you go up to the curve, up to the curve, and then across the diagonal, then you should be able to see, if you use graph paper, then these are the 2 intervals where you remain in 0, 1. And then we put these intervals along this axis. Again, you need to draw this accurately on graph paper. So after 2 iterations, you should easily be able to show that these are the 4 intervals. To find the fractal dimension, so it's minus log the number of segments. So at each stage, you can see there are 2 segments and then 4 segments. So each stage, 1 segment is replaced with 2 segments. And the scale, so from here, this is 3 over 10 to 4 over 10. So this length here is 1 over 10. So this gives us log 10. And if we evaluate this using MATLAB, you can see you get 0.3. So that's the fractal dimension of this Cantor set. And that concludes the solutions to question number 6.